All right, guys. Hello and welcome back to Mr. Marlowe's math class, spring break edition. Today we're going to be doing some review of factoring and distributing. All right. So my target is I can model and write equivalent expressions using the distributive property, and I can move from expanded form to factored form, and from factored form to expanded form. All right, that's a mouthful. It's okay though, I promise. Let's take a look at example number 1. Factor the following expression to find an equivalent expression. Remember, when we're factoring an expression, we want to break apart or pull apart that expression into two or more factors. Factors are numbers or variables that are being multiplied together. So I want to take this expression and I want to pull it apart into its factored form. Okay? And the way I do that is I look at 24x minus 36 and I ask myself, what is the greatest common factor, okay, with these two terms, 24x, negative 36y? What is the greatest common factor? Well, x and y aren't common factors, so I'm going to leave those alone. But is there a number that can divide evenly into both 24 and 36? Okay, let's see here. If I use my recursive division algorithm, I can say, oh, I think 12 goes into 24 and 36. 24 divided by 12 is 2. 36 divided by 12 is 3. So I can pull a 12 out of both of these terms. Okay. Notice I put that opening parenthesis there. And when I pull a 12 out of 24, what am I left with? I'm left with 2. But I didn't do anything with that x, so that x stays there. I keep the minus sign the same. And when I pull the 12 out of 36, I was left with 3. Now notice, if I distribute this 12 back into my parentheses, well, I would have 12 times 2x. 12 times 2 is 24x, right? And 12 times negative 3 is negative 36, and that y stays the same, so I did it correctly. There's my answer. 12 times 2x minus 3y. All right, let's take a look at this one. Factor the following expression to find an equivalent expression. Okay, so again, I want to find the greatest common factor of ABX and ABY. So what do we notice are in common here? It'd be a little bit silly to use our recursive division algorithm. I suppose we could, but it would be kind of silly, right? So what I want to do here is I want to see, okay, what do these two terms have in common? Well, they both have an AB. So I can pull that AB out of my expression. Okay? And if I pull the AB out of this term, what am I left with? I'm just left with the x. And if I pull an AB out of this term, what am I left with? Just left with a y. Okay? So, how does this expression factor? How can I pull this apart to two separate factors? I can pull out the AB, and then I'm left with AB times x plus y. All right, example number 3 says apply the distributive property to write an equivalent expression in expanded form. So before, when I was pulling things apart, well, now I'm going to mush them back together to write this expression in expanded form, okay? And I'm going to use the distributive property, okay? And if you think about distributing, if you're distributing something to your friends, right, you're giving each friend whatever it is that you have, okay? So in this case, we're going to distribute the 4 to the 5x, and we're going to distribute the 4 to the 8y. Okay, remember the parentheses signify multiplication, so we're going to ask ourselves, what is 4 times 5x? Well, 4 times 5 is 20, and we just keep the x. Okay, the addition sign stays the same. What's 4 times 8? 4 times 8 is 32. And that y, we're just going to keep that y. Okay? So we could write the expression 4 times 5x plus 8y. If we're going to write that in expanded form, it would be 20x plus 32y. All right, last one for this lesson. Example 4. Apply the distributive property to write an equivalent expression in expanded form. And this is x times yz plus 23. So again, I want to distribute that x to each of my friends inside of the parentheses here. Okay, the parentheses signify multiplication. So what is x times yz? Well, that's x, y, z. And what's x times 23? That's 23x. Okay? Again, I just took that x, that variable or number that was outside of the parentheses, and I distributed it to each of the terms inside of the parentheses using multiplication. Okay? So again, my target, I can model and write equivalent expressions using the distributive property. Check. And I can move from expanded form to factored form, and from factored form to expanded form. Check. Great job, and enjoy the rest of your vacay.